So we've seen the law of sines in action, but let's go ahead and take a moment to prove why it works. Because it's excellent to be able to use math, but it's amazing to be able to prove that math. Because that's how we start to learn new things, is we're able to apply all those old things to the new things. So without further ado, let's go ahead and take a look. We're going to start the same way we did the law of cosines by looking at a triangle. So here we've gone and labeled everything, and the directions are simply to prove that sine of A divided by A is equal to the sine of B divided by little b is equal to the sine of big C divided by little c. And again, we're going to start off exactly the same way that we did with our law of cosines proof. And what we're going to do is we're going to put our pencils on this C up at the top, and we're going to draw an altitude down, which effectively breaks this one non-right triangle into two right triangles. And again, just like last time, I'm going to go ahead and outline these to make them a lot easier to see. So here is that first one outlined in blue. And here is the second one outlined in yellow. So just like with the law of cosines, we have taken a non-right triangle and turned it into two right triangles. And now that we've got two right triangles, we're allowed to use Pythagorean theorem and those trig ratios, which is also known as SOHCAHTOA. So let's go ahead and call this line right here h, standing for height. And let's go ahead and look at some ratios that we've got here. What we can do is we can look here and we can say, here's angle B. Well, if I look at angle B, I can say that the sine of angle B, according to this right triangle, is equal to opposite h over hypotenuse A. And doing a little bit of rearranging, I found out that A times the sine of B is equal to h. So that's just looking at that little blue triangle right there. Sine of B is equal to h over A. A little bit of rearranging, and you find out that A sine of B is equal to h. Now if I take a look at the yellow triangle here, then I can look at this angle A. And I can say that the sine of capital A is equal to opposite h over hypotenuse B. Again, with a little bit of rearranging, B times the sine of A is equal to h. And it seems like we did the exact same thing, but it's subtly different because you've got those different angles inside of there and those side lengths. Yes, we used the same idea, but it is subtly different. What's important about this is the same h. In both cases, they're looking at this line right here, which means if A times the sine of B is equal to h and B times the sine of A is equal to h, then these two have to equal each other. I am allowed to write A sine of big B is equal to B sine of big A. And if you look carefully at this, what we could do is we could divide this side by B, but if we do it to one side, we got to do it to both. And we can divide this side by A, but if we do it to one side, we got to do it to both. The beauty of that is this A cancels with that, this B cancels with that, which means we're left with sine of big B over little b is equal to the sine of big A over little a. Using those trig ratios with that height, we're able to find out that part of this equation is true. So we have just proved that sine of big A over little a is equal to sine of big B over little b. If we can prove that either one of these is equal to sine of big C over little c, then we've proved this equation. So in order to keep this triangle from looking too messy, what I've gone ahead and done is kind of copied this over to another slide. So I'm going to kind of put a pin in this. We've proved this part down here. Let's go ahead and put a pin in that and see if we can do the same thing with a sine of C. So here is our new triangle. And again, I'm still going to put an altitude on there. But this time I'm going to make it a little bit different. I'm going to make my altitude crossing through A. So it's a lot harder to make that perpendicular line. But we can go ahead and say that it's perpendicular by just drawing those little right angles there. So again, I'm going to go ahead and outline these, and it's definitely not going to look pretty, but I'll do my absolute best. So here is our first right triangle, and I didn't do a super great job of making it right, but again, because I put this little box here, I'm saying, hey, that's a right triangle. And I can do the same thing outlining this guy in yellow. So now I've got two right triangles, because dropping that altitude allows me to create two right angles here, which gives these guys both right triangles. So I'm actually going to do the same thing here, but instead of calling it H, because I've already defined it in the last one, I'm going to go ahead and call this just J. Oops, sorry, still have the thick line on. Let's just call this J. Instead of calling it H, we're going to call it J. That way it's a brand new letter. Using my trig functions, I can look here and I can say, well, I know that the sine, excuse me, I wanted to do this in white. We know that the sine of big B is equal to, well, the opposite side. Well, the opposite side is J over the hypotenuse. The hypotenuse is opposite the right angle, so C. So sine of big B is equal to opposite over hypotenuse. A little bit of rearranging. We find out C sine of B is equal to J. And we can do the same thing with the blue triangle. If we choose the sine of big C, well, sine is equal to opposite. Opposite side is J over hypotenuse, B. A little bit of rearranging. B sine of C is equal to J. And just like with the previous slide, these are the same J. They're both that altitude that we dropped from A to side A. Sorry, angle A to side A. Which means I can set those equal to each other. C sine of beta, sorry, capital B, is equal to lowercase b sine of capital C. Just like last time, I'm going to divide both sides by b so that these cancel. And I'm going to divide both sides by c so that these cancel. And when the smoke clears, we end up with the sine of capital B divided by lowercase b is equal to the sine of capital C divided by lowercase c. And from the previous slide, we knew that the sine of B, let me go ahead and write this, the sine of A divided by little a was equal to the sine of big B divided by little b. This was from the previous slide. And now we know that the sine of B divided by the little b is equal to the sine of capital C divided by lowercase c, which is what we are trying to prove, all through sine trig function. So there is your proof for that law of sines for you. Split it into two separate triangles by once drawing an altitude from one angle to its opposite side, and then on another one you draw an altitude from another angle to its opposite side, and using that sine trig function on these new right triangles, you're able to set them equal to each other and discover law of sines is in fact true.